Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of set theory. Well, look at this question, quite a lengthy question here. 3 sets are involved, but the solution is very simple. Now, let us understand the question. There were 41 candidates in an exam. Okay, so total there are 41 candidates and each was examined in algebra, geometry and calculus. So there were 3 topics in which they had written the exam. It was found that 12 candidates failed. Alright, 12 candidates failed in algebra, 7 failed in geometry and 8 failed in calculus. 2 in geometry and calculus, 3 calculus and algebra, 6 algebra and geometry, whereas only 1 failed in all the 3. Okay, quite straightforward. Now, what you need to find? You have to find the number of candidates who passed, opposite, complement of failed. Okay, passed in all the 3. Right now, let us start with giving some names, some notations to this algebra, geometry and calculus. Okay, now for algebra we will take A, B and C, or shall we take A, G and C itself? Yes. So before that, let me write what is n of u. So there are totally 41 candidates. Okay, there are totally 41 candidates. So that is the rectangle. So in the universal set you have got 41 members. Now what about n of A, algebra? So how many have failed in algebra? So 12 candidates failed in algebra, and how many failed in geometry? So geometry is 7 and 8 failed in calculus. Well, 2 in geometry and calculus. So geometry and calculus is 2. Then what is the next detail that is given to us? 3 in calculus and algebra. So algebra and calculus, calculus and algebra, that is 3. And the last thing that is there is algebra and geometry. So algebra and geometry, that is 6. Well, now the last thing that is given is how many have failed in all the 3. They have failed in A, they have failed in geometry, G, and they have failed in calculus. Only 1 has failed in all the 3. Now start, if you are going with the Venn diagram, okay, start with intersection of all the 3. So you have algebra, geometry and calculus. So how many are there in the intersection of all the 3? Intersection of all the 3, those who failed in all the 3, only 1. So note, mark it, mark this region as 1. Then how many are there in A intersection G? A intersection G, totally 6. Okay, but you have written 1 here already, so write 5. So this total region is 6, only this region is 5. Fine. Then A intersection C, you have 3 but 1 is here, so write 2 here. And G intersection C is 2, so write 1 here. So this total region is 2. Okay. Now what is n of A? N of A is 12. Now from 12, this circle comprises of 12 candidates. Out of 12 you have written 8 already, so only 4 you got to write in this region. Then n of g you have totally 7. So 5 plus 1, that itself is 7. Therefore, there are no candidates here. No candidates here. So totally 7. So in this circle you have totally 7. Only G. Nobody failed in only geometry. No one failed in only geometry. Okay. There are students who failed in algebra and geometry. 5 plus 1. There are students who failed in geometry and calculus. 1 student failed in all the 3, but no one failed in only geometry. Fine. Next, continue. N of C is 8. So from 8 you have to subtract 4. So once again this is 4, just like that. Well, now this total region is A union G union C, is it not? A union G union C, that is this total region. Now let us add. So how many you have got? 4 plus 5, 9, 10, 12, 13 and 17, correct? So there are 17 students who have failed in at least one subject. Okay, so there are 17. So there are totally 41 who have taken the exam. So in the rectangle there are 41. So how many are outside the rectangle? How many are outside the rectangle? That is 41 minus 17. So how many you have got? How many you have got? Yes, you have got 34. You have got 34. So there are 34 people. 24, I'm sorry. So there are 24 people. There are 24 people who have not failed in any. So those 24 people are inside the rectangle but outside the circles. So don't confuse with this 41. 41 is the rectangle. These 24 are in the rectangle but not inside the circles. 41 is the circle plus this 24, those who are outside the circles. Well, okay, so that method is based on the Venn diagram, and that's quite easy method. Always start with intersection of all the 3. Always start with intersection of all the 3. Well, let us solve using the formula, then you will understand how to go about if you want to use the formula, if you do not want to use this Venn diagram method. Well, so shall we? So you have all the data that is given in the question. Okay, I have written the data. So let's use that data and find what is asked. So look at this carefully. What is n of A union G union C? So n of A union G union C is this region, union. So that we will find first. Then we can subtract that region from universal. Okay. So that's what we are trying to do here. So this is n of A plus n of G plus n of C minus n of A intersection G minus n of G intersection C minus n of A intersection C plus n of A intersection G intersection C. Well, let us substitute. This is known, I mean we do not know. We know n of A, correct? So n of A is 12 plus n of G is 7 and C is 8 minus A intersection G is 6 and G intersection C is 2 and A intersection C is 3 and intersection of all the 3 is 1. Well, that adds up to how much? So 12, 19, 27. So 27 minus 6, 21 minus 2 is 19, 19 minus 3 is 16 plus 1. You have got totally 17. Let me add again, I'm sorry. So 12 plus 7, you have got 19, 19 plus 8 is 27, so this is 21, 19 and 16 plus 1, 16 plus 1, that is 17 obviously. Well, now this is n of A union G union C. That's what we got here. When we added all these numbers, we got 17. That is the region enclosed by these three circles. Correct? Now if you need the number of students who passed in all the subjects, opposite of failed. Correct? That means we have to find the number of students who did not fail in algebra and who did not fail in geometry and who did not fail in calculus. That means they passed in all the three subjects. They did not fail in any one of them, neither of A, G and C. That's what we are asked to find here. So if you understand this, then you know the formula. N of U, number of elements in the universal in the rectangle, minus number of elements in the circle, that is union of all the three, and this is like 41 minus 17, which is nothing but 24. So 24 is the right option here. Okay, and you can use the formula or the Venn diagram. Choice is yours. See what's easy for you. Let's move on to the next example. Hello dear students, and welcome to CET JEE classes of the chapter set theory. Moving on to the 13th question. We have already solved 12 questions from this chapter. We have understood the concept clearly, and we have solved already 12 questions. So if you have not watched the previous video, please go back and watch those videos first, and then you start with this lesson. Looking at this question, we can understand that this is based on the concept of belongs and subset. Okay, so you should be able to distinguish clearly what is the meaning of this belongs and subset. Alright, so this question is totally based on that concept of belongs and subsets. Understand, let A is equal to set of all 1, 2 and the set containing 1, 2, 3. So this is an element of the set A. The set 1, 2, 3 is an element of A. So if I just name the set 1, 2, 3 as B, then A would be 1, 2 and the set B. So B, the whole set, is just an element of A. So make this very clear. You can say that 3 is an element of B. So 3 belongs to B. Okay. And you can say that B is an element of A. You can always replace this B, so that doesn't make any difference. So still this is an element of A. This is an element of A. So therefore it belongs. Elements belong. The set is a subset of another set. Okay. So only when you compare two sets, you use the symbol subset. When you compare an element and the set in which that element is found, you just use the symbol belongs. Get that very clearly. Okay, now when do I use the subset? See, I can say the set 1, 2, the set which contains 1, 2 is a subset of A. So that is one subset. You can just write one element and you can say it is a subset. You can write this set and still write subset as this. So you can say the set which contains the single element. This is a singleton set now, because it has only one element of the set A. This is just one element of the set A. So this is a singleton set, okay, and it is a subset of A. Alright, so now let us analyze these four options. Well, so keeping this in mind, Let us analyze the options and check which option is correct. Well, look at the first one. Look at the first one. You have got a set here and it is a subset of the set A. It is a subset. So this is not correct because they are saying the set 1 comma 2 is an element, belongs. This is not an element. 1 is an element, 2 is an element, but this is a set which is a subset of A. So they should have been using, they should have used the symbol subset. So this is not correct. Now what about 1, 2, 3? This is an element of the set A. This is an element. So you must use belongs symbol. Belongs symbol because this is an element. This is just one element, whole thing. Well, so this is also not correct. That is not a subset. Okay, even though this is a set, that is just an element of the set A. Well, now what about 1 comma 2? Is it a subset? Does it belong to P of A? Tell me what is P of A. I'll write here. See what is P of A. This is set of all subsets. So if you write, if you list all the subsets, first of all the empty set, okay, then the singleton sets. This is just an element, correct? So you must write that within another flower bracket. That makes it a set because P of A is set of all subsets. Subsets means it should be a set first of all, correct? So this is just an element, so use another flower bracket to make it a set. Then you can have the subsets in which you have more than one element. Okay, you can write this is a subset. You can write, okay, so you can even write 2 comma. So these are the subsets in which you have 2 elements. Now you can have a set in which you have 3 elements. So where do you have 3 elements? Well, so this is the one element, this is the second element, this is the third element. The maximum you have got is 3 elements, and that is nothing but A itself. Okay, so that completes the power set. That completes the power set. Now, is this a subset of P of A? No, this is an element of the set P of A. This is an element of the set P of A. Therefore, it belongs to P of A, which is the right choice. That's the right choice. So this is just an element of the set of all subsets. Set of all subsets. Well, now what about 3 belongs to this? Does it belong to this set? No, you don't have 3 independently. Okay, this is one single element. One single element. 3 is not an element of A. 3 is not an element of A. 1 is an element of A. 2 is an element of A. The set 1 to 3 is an element of A. But 3 independently is not an element of A. See, if you have written this, that would be correct. Okay, so 3 belongs to that. If you write the set 3, then it is a subset. Okay, so you can write the set 1 to 3. That is the element of this set, because this is an element, this is an element, so that belongs. But 3 does not belong. 3 does not belong. So the right choice for us is option C, and only that is correct. So this question is based on the knowledge of the difference between belongs and subset. Elements belong, set is a subset. Okay, well, so that is about question number 13. Now let's move on to the question number 14. So question number 14, if A and B are 2 sets such that A has 192 more subsets than B. So this is also a question based on subsets. Okay, not belongs and subsets, but only subsets. Well, understand this statement clearly. A has 192 more subsets than B. Okay, now what is n of A? We do not know. Let me take it as M, and n of b, let us take it as n of b, let us take it as n. Now what is the number of elements in the power set of A? That means number of subsets. What is the power set? Set of all subsets. Number of elements in the subsets is nothing but number of subsets. Alright, so that is 2 raised to m. That is the formula we have got to find the number of subsets. And what is the number of subsets of B? So that is 2 raised to n. Now I hope this statement makes sense to you. So A has 192 more subsets. Alright, so A has 192 more subsets. Alright, so that means 2 raised to m is equal to 192 plus 2 raised to n. That's the meaning of it. Okay, so you have 192 more subsets in 2 raised to, in A. Well, if this equation is clear to you, now we can find the value of m and n. So that's what you have in the options. You have to identify the right choice of m and n. You can use the inspection method and find which suits your purpose. So you can substitute m6 and n2 and find if that is true. Alright, so you have 2 raised to 6 minus 2 square. Okay, so you have got 2 raised to 6, that is 64 minus 4, that will be 60. So that doesn't match. Okay, so therefore we have to go for other options. So you have go to, let us say, 10 and 4. So if you put 10 here, 2 raised to 10, okay, minus 2 raised to 4, 2 raised to 4 is only 16, that doesn't give you 192, and you have got 2 raised to 8. So if you're going for third option, okay, so m is 8 and n is 6, then this is 2 raised to 8 minus 2 raised to 6. So what is 2 raised to 8? 2 raised to 6 is 64. So that is 256 minus 2 raised to 6 is 64, and that gives you 192. Right? Only that will give you 192. Well, now if you take 8 and 5, does it give you? No. If you take 8 and 5, that will be 256 minus 32. So only the option C gives you the right answer. So you can go for the options and inspect whether you get the right required answer or not. Okay, so just put n of A is equal to 8, n of B is equal to 6. You have got the answer, therefore that's the right choice. So this is one of the method to answer the multiple choice questions. So when you have the options given to you, you can always use them to check whether the statement holds or not. So if it holds, then that's it, that's the answer required. Well, so I hope you have understood this question. So thank you for watching. Well, dear students, moving on to the question number 15. In a class of 175 students, the following data shows the number of students opting one or more subjects. So the data is as follows: maths 100, physics 70, chemistry 40, maths and physics is 30, maths and chemistry is 28, physics and chemistry is 23, maths, physics and chemistry, all the three is 18. All the three is 18. The number of students who have opted maths alone, only maths, that's what we have to find. So let me write the given data first. We may not need all the data, but still let me write that quickly. So n of u is 175, and then I'll take ABC. Okay, so for maths, chemistry and physics, or if you need, I'll take maths, physics and chemistry itself. So you have got 100, and then you have 70 in physics, and then chemistry there are 40 students, and maths and physics is 30. Well, and then maths and chemistry M intersection C is 28, and physics and chemistry is 23, and finally intersection of all the three, physics, chemistry and maths is 18. So that is the data which is found in the question. We have written that. Okay, you don't have to write that always. You can directly go for Venn diagram, get the answer very quickly. You don't have to waste time in writing this data. I am writing this only so that it becomes very clear to you. Well, so now let us draw the Venn diagram. You have got three things here. So maths, physics and chemistry. You have the rectangle, that is universal set, okay, U. Well, how many are in the intersection of all the three? So write that first. Always keep in mind, go for this region first. Then you can go for the region of M intersection P. M intersection P is 30. See, this region is 30. This region is 30. Therefore, this must be 12. Correct? Then M intersection C. M intersection is 28. So that means this must be 10. So total must be 28. So only this region exactly M and C is 10. Well, next P intersection C. P intersection C is 23. That is that region. So you have 5 students only here. So totally it is 23. So total this region is 23. Next, what is n of m? Now itself you will get the answer. Okay. So what is n of m? So that is 100. So out of 100 you have to subtract these three things. Okay. So out of 100 you have to subtract 30 plus 40 out of 100. So that gives you 60. That's it. That's the answer actually. Well, if you want to fill the Venn diagram and finish it, so what is the n of p? That is 70. Out of 70 you have to subtract 35, and then n of c is 40. Out of 40 you have to subtract 33. So this is only 7. That's only 7. Well, now what you had to find? You had to find maths only. So that means you had to find this region. So you had to find only this region, right? So you had to find that region. So what you need to do is you have to subtract these three quantities from n of m. Okay, so number of elements in m only is nothing but n of m minus if you need the formula. So that is n of m intersection p minus, you have to subtract this region also, m intersection c, but you need to add something here. Why? See, when you have subtracted this region, you have subtracted intersection of all the three once. When you have subtracted this region m intersection c here, you have subtracted this 18 intersection of all the three again. So twice you have subtracted, but you have to subtract this 18 only once out of this circle of m. So what you need to do is you have to add it once. So please bear that in mind, okay, if you are using the formula. Okay, so this is 100 n of m minus, what is this, m intersection p, that is 30, and then m intersection c is 28, plus you have to add this 18. So when you calculate that, minus 28 plus 18 is minus 10, minus 10 minus 30 is minus 40, so 100 minus 40 is 60, and that's the answer we have got using the Venn diagram. Well, so if the question is only physics, that is 35. If the question is only chemistry, the answer is 7. So using the Venn diagram, you can clearly get all the answers, but you should know how to draw, how to mark these regions with their appropriate numbers. Well, so that's it for this chapter, set theory. In the next class, we'll start with a new topic. So thank you very much for watching. If you have not understood this class, please watch it again and make sure you get this right. So once again, thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.